model it in the software also. Like readily available software with Groovy and you can model it. There are nowadays so many free versions have come like blocks. Every primitives are available like Cube, Prism, all those things. They can just assemble and make also. On the structure. This is called meta structure. If it is like molecule level, also the chemistry and chemical engineering people are working with multi-body dynamics. When it comes to the bigger mechanical, these shapes, generally mechanical properties are material dependent. But these properties, not only material dependent, they depend on the shape of the geometry, whether how many hexagon, what is the wall thickness, what is the radius of side of your regular hexagon or modified by express structure. So those parameters are bringing the cumulative shear modulus because this structure requires a core. So core will have plate to plate shear. When you are bending, the plates are getting shear. So the core should provide higher shear rigidity. So higher shear rigidity with the damping. How it build? That's the advantage. So earlier we worked with glass, which is actually 70 gigapascal smaller. When you go with the head, it is 58 to 70. But when it is continuous fiber, you will be able to get such a higher model. When you use a particulate, you will not get that. Maybe 1/10 or 1/5 of its parent material, you will be able to get. We use the particle and we started with 0 to 0.55%. After some time, it becomes so brittle so that the affinity between the PLA and the hem is not much, so it getting broken. We start up to 5% of hem with the PLA. So the PLA will be readily with the bonds. Then we can chop those hem and it mix like this. We fine tune and brought it to 200 to 250 microns. It's not nano, it's a micro composite. Then with the PLA pellets and you can mix with the temperature 170 to 185 with the screw. So it makes and creates the filament. So it should have 1.75 is the general filament radius of the MDF printer. So when you increase the hem content, it is going bulkier. So we stop up to 5%. This is the method. So we go with the pellets and dry, crushing with the milling, and then we put the powder, extruded that. So we got finally PLA plus M. That's why it is 3D printed composites. Because we have added the hem, two constants. The matrix is here, your PLA, reinforcement is M. So it's a 3D printed composite. So how it is going to help when you make this curvature structure? Then it is printed before we can't see curvature structure. It's a 3D printed structure now. So it's an extruder they make. Actually, it is available in Pune. It's a large place in Pune. It is available. So we outsource. We are not there. Even you can make 2-3 lakh small machine, but we'll be able to get the extruded 1 kg, 1 meter, or half a meter. With that, the repeated products you can't make it. Because when you are trying introducing the structure, you need to make n number of specimens and you have to adapt the repeatability while testing. Okay, so first what we have done, we have taken the filament. Filament is made with the ASTM standard to check as an individual filament what is the mechanical property. Taking smallness, the tensile strength, we got it, and that's the purpose I'll tell you later. So we got this individually, and then for various percentage of hem with the PLA, and we got this property. See, I have shown the individual hem has 58 gigapascal is small. The PLA may be 2 to 3 gigapascal. When it comes with the smallness with the pure chemistry, what was your hem? But when it made particle with only 5% or 2.5%, it adds very little in that. When we look at the tensile strength, it is reduced. So when tensile strength is reduced, then why do you use this? Because actually we want PLA, it gives reasonable shear model, but we need to have a damping on it so that this curvature structure, it will be brittle in nature. When you apply a load, it should damp certain energy. So damping property is improved when you add a M. If you want stiffer or doubly stable, you can add a carbon. There are other ones also we have done. Here I have shown you. We can add carbon dots, carbon nanotubes, graphene pad. If you want mechanical advantage, and the thermal is stable. So here our purpose is to get the damping, and damping you will not able to measure with the simple UPM. We need actually, I'm skipping this. We need actually dynamic mechanical analyzer. So it actually happens in the vibration mode. So you get dynamic responders, but it is available in very few places, in fact, to some places. And we found that an ASTM standard, this is ASTM E1876. You may be heard in, you could have also done in your UG undergraduate. There will be a beam simply supported. You will apply 1 kg, 2 kg, 3 kg, then road versus deflection. Then you will find the installers of that particular bar. That's the concept of this D series. In ASTM, there are C series, D series for destructive. The E series is for non-destructive. So we make a specimen like 150 mm length and 50 mm breadth, the fiber thickness. We just kept in two modes. One is simply supported. Then we are using vibration instrument to excite it. When you hit the hammer, it goes to elastic limit. Certain range it goes and it converges. So you will be able to get the frequency. So you know that frequency is a structural property. For a rectangular structure, you get the frequency, but frequency is function of stiffness and your mass. So you know that density, stiffness, it is like, you know the cross-sectional values. So E is there. So you can find the X modulus of this. In that way, you got X modulus, it's called dynamic X modulus. And when you have this X modulus with the fundamental thing, and these are the structure which is made the X modulus. The CAD model of that. These are 3D printed. It is about the shape of the honeycomb. For three variants we are using. One is honeycomb. This is actually beetle. This is lotus. Lotus inspired. This is regular honeycomb to get by comparison. So it has been sandwiched with the galvanized. Then we are testing it. So when you test, we get the peak. When you get the peak, you will be having frequency. And some of you may be heard about half-power dam method. When you have a frequency, the adjacent band, you can put a band. So what is the lowest and highest frequency? With that, you will be able to get the damping loss factor. So in every cycle, what the material is damping, that can be taken as a loss factor. Now the PLA with the hem, it's not simply elastoplastic material. It's a viscoelastic material. So it can be modeled like a viscoelastic with X modulus plus the tan delta, which is we can arrange your storage modulus loss modulus as a cos and sine. So the angle what becomes the tan alpha will be considered as a damping. In that way, the students have found without dynamic mechanical analyzer, when you make a filler in the PLA is also very, it's a polymer, so it's a viscoelastic material, but the rate of the value will be lower when it is a simply PLA. When you are adding the hem, basically all the plant-based fiber is giving damping. All the plants will have the damping behavior. So that affinity between PLA and hem is intact, and it is showing certain damping. So in that way, the material chosen is good. But how much elastic property is going to be? Now what we have done is about basic testing. Now we are introducing the virtual testing. Like it's a new phenomenon. Maybe few of the mechanical may be aware. Otherwise, you can also do. There are software like ANSYS, Abacus, SAP. There are so many companies, Hexagon, DigiGrant. There are so many packages are there. You can do really whatever experiment you are doing in UTM. get the shear rigidity, and then compression. All those things you can do virtual testing. How you will be able to do? Whatever you have made a specimen. So it's a CAD tool. So we have a CAD model. The CAD model is imported in the ANSYS, and we'll give the material property of the filament. That's what we did in the beginning. Filament we give as a viscoelastic material. So it has a ducting, it has basic elastic property. So when you give the parent material, whatever shape you make, when you make the cell size bigger or smaller, when you increase the wall thickness, when you make the different by-inspired cell structure, then you will get a different set of properties. So before going to 3D printing, everyone is not available to get massive printer to make and testing. It need a casting. Cost is very heavy. So if you go a simple CAD model to Autodesk Fusion, it is already free version. If you have 50,000 rupees FDM printer, and when you have student version of your ANSYS or Abacus, whatever it is, student can make with the Autodesk Fusion the model, can virtually test in the software, they can get all the properties. When the properties are coming, you may take whatever properties are better. Those better by-inspired structure, better constituents of that material can be printed and validated. The simple work can be published as a result. In our domain, it's very simple work, but it has been published. This work is published in Journal of Natural Fiber Mechanics, Mechanics of Advanced Materials and Structure. And now I have given in multidisciplinary structure and engineering reports. These journals, it is easily accepted. It's not a great work, but what we have done, comprehensive work. So the people who think, basically I'm from computational mechanics. We found students are weaker nowadays, PhD students. So I have come to this fabrication, but still need a computation flavor. So one can, how will we? A layman who knows little bit of materials, little bit of 3D. Even I am not much aware of much of principle in 3D printing. How one can enter into small business where this virtual testing will give all the property. When you have list of these property, now you can bring a friend of computer science faculty who can put your AMR model for predicting. If you make bio-inspired with meter and your bamboo, you have done with the classical honeycomb, then there are so many inspired, nature-inspired codes. So if you make some 10 variants, you can ask your computer science faculty how much data virtually can be possible to do. In student version, it is global. You don't need higher mesh in ANSYS or Abacus or in the SAP, whatever student version, it is smaller. You populate so much of data, then work with the AI model. You can predict the fused version, like in bamboo and your beetle group, it is mixed. Then what may be the probable property will come. I have shown, since my application is sandwich, I have shown only the shear property. You can do a smaller, you can do the lab shear. Somebody may be working, chemistry people can work on other sieve. After printing, one can put a different other sieve, or one may be doing one layer, maybe for if it is 5 mm and up to 2.5 mm, you can go with the PLA. After that, you can find a better adhesive, you may go with the ABS. So like that, you can cross over with the material availability in the 3D printing or resins, which may be tailored. You can't go simply a single dependent product. A single rooted 3D printer will always have a flaw. As we have discussed so many things. What are the disadvantages? Infiltration density, and somewhere if the temperature process change, then there will be a small void in the 3D printer. When you are using that mechanically relevant, mechanical load to bear, the crack will obviously will collapse. I have other interesting study, but I have not shown. When you go with the dynamic method, it's giving like 100 megapascal of shear moment. When you go with the rooted 3-point bending, 4-point bending, it is even giving 10 megapascal. Because when you go with this dynamic method, we are not allowing to failure. dynamic modulus, it is giving improved property. When you go with the static, it is almost one tenth of the property you are able to get, because based on the real, there is a micro cracks, voids, and it creates, when you go with the static like 3-point bending, 4-point bending, with that also there is a ASTM B7249 and 50. By combining that, we will able to get that time 1 by 10 it is reduced. We have accepted, we have proved the dynamic modulus is good. It has published in high impact factor, 3 impact factor journal. But same author now with 4, we are writing another article by saying that this dynamic route is wrong. Because when you go with the ASTM B7250, it is even giving 1/10 of the things. This progressively nowadays PhD students, they are very urgent. When you get some data set, they write and paper is published. When you are doing this as a structure, we got the property, we made a structure, and we have done the simply supported and cantilever for both structure. When you put that destructive expander, it's validating. When you put that non-destructive, means dynamic expander, it's not validating. So end is, when you go with the dynamic, you may get loss factor, but you will not be able to get the actual expanders, which is getting the actual strain energy in the structure. That's the end outcome. Thesis, but still we put our conflict in our own thesis. This is not, and we have this not at all. The approach is which is used for tailor-made conventional process. In both of them it is same. Some difference will be there. But when you go 3D printed, it's not working, because when you get slicing, when you are slicing, it has so much of changes in the process. When you are slicing, the primitives are, the entities are changing. When you are processing with that particular rate, when it tailor as the conventional material, it will not be able to do. So that's the proof that you have to still go with the classical one, with the 3-point bending, 4-point bending, the conventional ATM, UTM, you have to do that. Then only you will be able to process it. So in this process, we come to know, even you add the fillers and with the PLA, it gets improved property, but how do you justify it? Even ASTM standards as a restriction. Now you have ASTM standard for steel, different. ASTM standard for glass epoxy, different. Carbon epoxy, different. Fiber orientation wise, different. Polymer thermosets are different. Thermoplastics are different. So this ASTM also is, you can see the ASTM journal. Every year there is an updation that 2004, the 3D printing still standardizing. Yes, we can believe on the process, and we may go ahead with the proper tailoring of material, which is mechanically sound or structurally sound. This mechanically sound or structurally sound. So mechanical. Otherwise, like if you are making a breadboard, it's easy. If you are making a cushion for this Cinza or something, it's okay. If you are making hardened robot arm, there also considerably structural involvement. So the limitations with the lifestyle purpose or aesthetic purpose, it's ruling. But truly speaking, there are people working on this continuous fiber to tailor the higher advantage. Standardization is the problem. When we are working on it, when we have better facilities, definitely our people also will work and get the better version of printer, where we will be able to do as we did for EDM, as we did for CNC machine. What are the statistical technique we follow? We follow for 3D printing also. But finally, we may be able to get the controlled process, which will give structurally and mechanically the advantage. Similar to this, we have done other work also with different shape. These are advantages when you work with the structures. This is like bamboo inspired. So bamboo inspired, and here the next one PLA with the different infiltration density. This is the process. Now recently, you don't need a big software. Even MATLAB and Python programming, if you give a simple lattice, your one period of your this meta structure, if you model, and you can arrange in row and column, or you can see large language model you can switch. You can use the coordinate of small external things. And you ask to make a period with the 10 period in the x and 10 period in the y. You can say that you can import and create a model. In open sources, it is possible. Model, you can save it as a drawing file or whatever file you can save, and you can adapt with the slicing and it can. This is Gaillard. It's about human bone. In Gaillard, it has a multiple shapes. So the human bone has multiple shapes, Gaillard, stage was diagram, stage was primitive, because it has so many clusters. Either standalone or by mixing it, one can make a bi-inspired coordinated structure, and which may be useful for the your quasi-static structures, like packing material and all quasi-static structures. This sort of material can get benefit out. So this is the one we can go with the hybrid view where you have different structures. You can create by inspiring the natural. You can create your synthesizing by adapting even the AML techniques when you provide large data, and this is one type of work. Studying to us, my good student is now working in. He supplied the content whatever I presented in the beginning. He is working under Additive Manufacturing Society of India in Bangalore. And the next is Sputnik. It is the contribution of PhD one. He is working in an Institute Institute of Sharda University. And Dr. Muthukumaran, he also works on this. Now he is working in a startup as a director in research. He is working on
सर्टिफिकेट भी होगा इनका। हाँ सर्टिफिकेट भी रख सकते हैं। हाँ यही वाला सब्जेक्ट क्या हुआ था मदर इन एक्सपायर हो गया और पटका भी
modeling and 3D printing. With that, we are having less students in mechanical, so we utilize computer science students. They made so many products. Faculty are involved with small conferences. When it is stabilized, they may move for quality journals also. It is possible to this is the acknowledgement. And I have some reference for research related to the mechanical base. I don't have reference for 3D introduction to 3D because it is compiled by Additive Manufacturing Society. Thank you. It's a big of a after 3 years I am speaking to you. We were busy as usual, everybody in me, and I had a break on my administration last 6 months. We are actually working on, especially this lattice development we are working. Instead of working the big packages, how the molecules level we can work. And recently we have taken carbon graphene, how molecular dynamics, chemistry, and chemical engineer does. We have done by maximizing in the axis how those carbon-carbon bonds and van der Waals between the carbon nanotubes, how mechanically we will be able to orient radially and longitudinally whatever the stiffness it comes by considering the carbon-carbon bond 5.74 terapascal of a smaller DHO. And we have done and almost it is also in the preparation. So we have to work interdisciplinary, we have to work on programming and some of the simulation. Then we have to take so much of data that we can easily work with. Now also I suggest my students don't use the plugins which are available in MATLAB because we don't know what algorithm available is. Even my student is not aware what is the shape parameters justified. He knows that it has come through the figure we have submitted. In good journal, structural engineering and mechanics, it is the faculty journal published. Because journal is having so much of hunger. Wherever A is there, okay, let it get accepted. So let's promote so that interdisciplinary will work. So it's a type. We were also having difference in our. Let me take a minute since you are multidisciplinary. We have difference with computer science faculty, their salary, mechanical faculty, less salary. But still, now if you cross work, if you are just accepting that they may be very much good in AML, but we have certain mechanics, we study mathematics, we have mechanics, we have packages, which are easily not requirement whether damping are thermally stable, are mechanically stable, are structurally stable. We can have a common problem with simple, whatever I presented is very simple. After purchasing, we started this research and we came with good one. Otherwise, basically, I'm working on computational mechanics where aerostructure, bending, flapping, rotation, centrifugal, Fourier. That's what my research in the first 15 years. Last 2 years, I'm coming with the recent work, whatever students are, we can't go against students. Anyhow, they should support us. So in the student point, we have come down, and here also there is a lot of scope. There are materials engineering, mechanics. Mechanics is even easily we can understand them. So instead of using those software that Atal or Python inbuilt program, mechanical engineers should work with computer science. They should understand the algorithm and how it is concluding that it gives this MSC or whatever the standard deviation lesson. Then better you can justify when you add them to author, when you work. Then there are multidisciplinary journal. Accepting when the author is from once editorial is crossed, your paper will be published because everybody has an anger of publishing. When my paper is rejected, I feel we will have low confidence. We'll give major revision. Let editor reject whether accepted or not. So editor rejection to avoid, when you go with multidisciplinary, even in simple institution with small setup, one can start a research. It will help even to do our own PhD or we can. And then even with a graduate student, we can learn that the students are exactly they are graduate students. Since they have traveled from other countries, they need importance of research to get direct PhD and master's in foreign. They are spending extra time. There are regular students are busy Instagram or these things and it is global. When you provide a little setup, it is global. This I'm concluding. Thank you, Dr. Sunil and lead coordinator. And I also very much eager and somehow I think I have come to the good place to get an exposure. I am also still junior in this area, like 2.5 years I completed. Many questions are there. Lunch time.
Sir, in that slide, which slide you have mixed the ham to the 2.5 and 5%.
That's what I told you. We tried with 2.5, 5, 7.5 term. Because we have done in the pudding. There is a extruder, commercial extruder. We have given them hem particle. We told them to make. So when he is making the filament, after 7.5, it's breaking. Because the content of hem with the affinity of the PLA, it's the spool to create. And as well as it becomes bulgier. So our 1.75 mm only, the plus or minus formula, the nozzle is there for a beer.
Also main code behind 2.5 and 5.8%.
No, we could have started with 1, 2, 3 also.
Okay.
We thought that it is lower modulus and the natural material. So we thought of going with a bigger gap, like even more. So it can bind. But these are like micro size. So it may not, it may give some kind of approximation and all. So we decided let's go with the 2.55. Even then it dispersed. It's coming as a filament. It's a trial actually. We started this trial whether PNA will able to give damping arm. So it is giving. So 7.5 and 10 we avoided because one spool it is 6,000 rupees. So they made with 0 to 2.5. It has come. The size also is around the 1.75 speed and approximately.
So multi-failures can work for this? Like
Yes, it works. Multi-pillar it works. But again, that what is your FDM printer? What is the nozzle size? And when it is extruder, when you are mixing, when you are drawing it, the spool should come. Then it will. People are working now. They are trying. Other students. This is like a standard. One template research like we do EDM. Then there may be some 1,000 paper in the EDM. Every process you publish. Then again 1,000 paper will come. What you change? I change encodal this grade. I change stainless steel P304. Only I will change the material. all it's a rigor, it's a mechanical technique to predict. So if predict, then we got better paper. It has been for so many scientists also. Other courses are there.
Did we go for SID properties to check structural behavior those components?
Yeah, we have done also. I skipped those things because we have to show that research in oxygen, all we have to show. Because it's a micro, even normal microscope. It's an atom problem. Sometimes you can tell a comprehensive story. When you say in multiple directions a story is interesting. When you go in narrow one particular thing, when you do a rigor, that is also research. Nowadays, depend on ability of student, is part-time student, he will come in the evening, printer will not be available, some student will be doing. So with the whole stuff, we try. It's a kind of a template one can start, and when you start with the carbon carbon dots, mechanically it's not good. Chemically or like photo related, sensor related it is good. But for mechanically multi-mole nanotubes are good because it dams and it is always longer CNT also it does something if you do some solution analysis. So there are machines like mine. There are certain companies, filaments are coming multiple. They are dying into resin bar. They are printing. There are things, but in our country we have very like I did in China. I moved to DIT University. Now we are working with the customer vendors to start a printer. But it is 26-year old institution. There is no single printer. So now they are printing. But the students are having printer for other purpose, like this Baha events, there are mechanical, just to marketing, we do so many things, essay Baha, this Baha, nobody will do any article, design equation or any analysis, nothing they do. They say that, no, Baha, they given the standard, we made the tube, they built the pipes and do. There are some push, trial and error, what is the acceleration. Students are doing, getting, they are also more and remembering write that stereolithography. If you ask me to write, I will not. Because I habituated to use the palm, texting. Entrepreneur spelling. Entrepreneurship I can't write. Because I am from Tamil medium, I can't able to get something. Still we are doing our regular activity. So we should accept nowadays every faculty complaining, oh in our time students are very great. We ask to target the faculty. We corrupt students are only our stakeholders. We should only work for them because they are our stakeholders. Whatever level they come, we have to come down. Now, if you ask 2K faculty, like 2K kids are faculty, they will not have such worry. Like me, like 80s born, 70s born, 90s born, they'll have worry because you prepared for gate after B10. You studied so many numericals, you know all the shortcuts, how to find eigenvalue, how to find everything you know. But nobody is attempting for gate now. Our curriculum is NCR changed everything. Only IITs and MITs, they are struggling now. They are not getting PhD students. They are not getting PhD students. Their research outcome is reduced because we are not producing the best students. Where they do MTech, when they will get PhD. So now I am sure that in next 2 years, core engineering, especially from electronics and automation, is very much moving. There will be a multidisciplinary program. There will be classical program like BTech mechanical, it may be robotics engineering, it may be mechanical engineering. Like this, it will come. Even that machine vision, like semiconductor, like depends on application. Like robotics, so many robots are required for industries like Amazon, Flipkart, for right time delivery. So industrial robots are more. So industrial robots for mechanically it's very small, but mechanical stability that's the result. But we are not able to do because we are mathematically not sound. We know that efficiently we are trying to make small robot, but when it is moving from here to there with the high radar and all, they work with the high frequency. We can. It is our mechanical problem. But we are not able to do. We are still going and asking this idea of this Python project. We are working. So you have your own code. You concentrate so that the multidisciplinary product will come into since this also is an immediate result, we want to complete that student because I am going to leave Sharda and he submitted 6 months before thesis. You have to wind up. Okay, you are not able to. It's an actually optional research. After entering into the field, it is also one kind of area we can do. That's the thing. But if you want to work in robotics or automation, mechanics like gyroscopic effects, electrical effects, mass center, whatever you study, area, center of mass, stability, equation, derivation, that we have to program and bring into stable rewards are kind of principle. Instead, we are in the team, we are also, it means I also say, like we find easier way because lot of culture. So many MBA work, CAC work, data manipulation, we don't have. I must thank the DIT University have not entered into this MBA or big things. So now we are working on federal maybe next 6 months if I am getting some questions and I will also talk opposite. Now I am taking this one security. Maybe many administrators are there. So it's a good thing is that bust the ego, make the interdisciplinary. Your journals are becoming now commercial. If your editorial is passing, your paper will be accepted. So there must be a level. There should be like disruptive technology somewhere it should be. Otherwise sustainable. Like PLA we have chosen instead of ABS. PLA is a biocompatibility. So we can put sustainable one word. So that also nowadays institutions are appreciating. Increase ranking, D ranking, sustainable ranking. Many things are now. It's like commercial. We have to pick. And for this also we have to put a fitting. What we supposed to do in 5 years research. What are we supposed to do? We are going to grow. It's core engineering with applied and computer. If you together grow, then definitely will grow. If you put standalone pass, then it will be very difficult. Individually, it is very difficult to grow. When you are getting maximum students, your speed may be good. When students are lesser than they are asking you to retake, no increment, will saturate. Mind is corrupted, then you will not be able to do. Like other institutions like Sharda, many institutions they started incentives. Like applied science and engineering, core engineering, we are now one school. We are treating like a stage. You publish paper, you get incentive. You will not get promotion, you will not get increment much. Because you are capable, you are engineer, you are applied science, you make paper. Computer science, they work on student load is more, conference is there, they take. So management, FDP, their revenue generation will training for small industry. Now this bank and NPA structured us. They disintegrated us. But if there is a point like this, if you come out and one faculty, Amrita from Chada University, she is from computer science. She is not understanding mechanical aspect. I have one other work, delamination modeling in structures, in composite structure, JFRP layered structure. She just taken the data, it's something 9 lakh data for 2D lamination, 3D lamination combination. She also take the same 10 algorithms she has chosen and made some graph with my basic validation I attached that has accepted in one other channel. So you accept now the interdisciplinary mindset. Obviously it will happen. Earlier if you talk to basic side, what is the TG or epoxy? Initially I was very interested to know about epoxy. You don't know this is like they talk about this carbon, oxygen. So we got okay we come. This is epoxy, L by glycine, this is order, okay mechanically it is level. It is like other level. So I can start with my level. Sometimes you have to listen, you have to be patient when you research person is coming and your little awareness or little content will help them to take. And if these were publishing, then only that people will listen when you publish, they will listen. So you publish. Right now, this I came from IIT Madras, IIT Bombay. After that you are there, you will do. After IIT Madras PhD, you will be able to get a candidate to serve in IIT from IIT Madras. If you sitting here without facility, what you will do? Because he is having that mindset from IIT. You have to come down and listen to the already experimented optional. When you do, there is a scope. Otherwise, it becomes redundant. So much of toxic things have transferred in academics. This toxic things get converted into beautiful one when you are interdisciplinary sound. That is good. With the computer science budget, you can find printer and that can be kept in the chamber of CSA. But our students can go and do one to school. Yeah, they have budget, they have student income, they can purchase, but we cannot do that. That ego is bursting, definitely. We can go in a progress. It is happening. I'm sure the witness. I think we will do. Can you go more to see? So that's what I'm saying. Now they are experimenting. Even as I discussed earlier, the bricks they are not making. So there are 3, 4 ways they are doing. They make those reinforcement, the speed wires they make. There are 2 ways they are using this aggregate. There they are pouring the aggregate. This is one way. The other way like basic bar, like epoxy and this laminated glass also they have experimented and they put the structure already built. They are just pouring the resin bar and they do heat treated curing and after that it is baked. These are like that's what I'm saying. When you ask, when you talk about 3D printing, the one word you remember, so you will be alert. Standardization. Standardization is first we are doing. After multiple people are doing, so many research articles comes in. That's why 3D printing papers are accepted faster. So he has some view, he has some perception. Let it be published because mostly nowadays journal are open access or choices with open access. I also find some started. The students are from Tamil and Nigeria. So I have used it as a corresponding number. Same journal earlier 2 years before, it's a subscription. Now it became open access. That's going to be another challenge. Every journal is coming into have any funding for publishing. Even real good journal is becoming open access because every country is paying for them. For us itself, our management is not able to pay. Then how they do? Like institutes like VIT, SRM, they are paying for those individual amount, like 7,000, 5,000 USD, they are able to pay for a paper because if citation comes only, they will be ranking in UPS ranking, ranking, then they will sustain student fees and all. It's a market. So that's the way we have to do. When they are encouraging, we do. Like myself, I started 2 years before. After 1.5 years, we found the approach for this is now. Because if we tried one, if digitally it will perform great, but when mechanically we press it with UPM, it is underperforming. So that way, now you will get when you start working, even dental, they are just it's a technically it's not strength based now. Older people, aged people, for decorating, for low strength. So the dental it is happening growth. But whereas that particular printed one, mechanically stable if you want to make, it is even simple packing material, it won't suit. So that's why they are allowing. It's a time. Those who are now starting research in next 10 years, you maybe I started in 2013 my first paper came. That time carbon heavy first time I asked some question. Nanotechnology, nano mission is there now. You put carbon dot, carbon, it will be accepted immediately. Now if you put carbon, there are so many questions they will ask. What is the lattice, whether it is half chair or zigzag, how you identify, whether it is industrial form or it is it's a nano in both diameter or length, or it's only one two. That time only diameter is nano, length is in micron. We published. Right now it is rejected. So it's the time for 3D printing like digital, like 3D modeling. That's why when I was enrolling in Sharda, first year load they were asking to remove from mechanical. So we made one course 3D printing, 3D modeling and 3D. So 3 months, 2 months they will work for modeling with Autodesk Printer. It's a free software. And with the 3D printer they made some model. So they gave some positive comment and management. So mechanical guys also doing something. So we they had some factory equipment, they work together. That's the way they are. So that give us some kind of confidence. So low hanging fruits we started. So paper has come. That's the way out. So you should also accept core engineering. Either they are mathematically sound and they have rhythmic process. They know that how evaluation happens. In such a way they can able. That's the way they reach. How carbon-carbon covalent the bond 5.7 for gigapascal. It is given by molecular dynamics. We simply take it as a mechanical engineer. We brought as a nanotube what will be the exponent, not on the molecule. So that's the way disciplinary has come. So that's an advantage. So this is the work. It answers. But before that, how do you model? We don't know. When we look at the literature, carbon-carbon is approximately 5.74 terapascal. You can able to do. They gave even bond length, everything they have given. Now MATLAB makes that there are so many nanomodules also. You pick the site, it will give MATLAB code. When you are running an ANSYS, it directly model. You have to do model IGS, then it will come. Now I can run from MATLAB ANSYS, opening from bin ANSYS, run post processing. I can take from MATLAB. So that's the way interdisciplinary. Now open access also good. Every article you will be able to read and do it. I want we should be like a family, not decide that later. We should there and start. When you see advantage, you never lose or you not get the difference. That is any other.
Thank you so much, sir, for sharing valuable insights and your expertise with us today. The session has been incredibly informative and thought-provoking. I would now request Professor Dr. Vinay ma'am and Professor Dr. Suman ma'am kindly come forward and present our speaker with a token of gratitude and appreciation in form of a memento and a padka. We request Dr. Sunil to please join. And we are very much thankful to Dr. Sunil for providing us such a wonderful resource person, our first resource person. Sir, your talk is very, very informative and we are highly thankful to you for sparing our time, your valuable time for us. Coordinator ma'am, Dr. Vinod Kumari ma'am, please join. A big round of applause for Dr. Anand Babuji. And so we will keep on inviting you at height, and we wish that we will guide our students and faculty members also. Yeah. So please spare time for the pilot so that the faculty members and the students are able to have such kind of process.
रजिस्टर करवाए थे
करवाए थे कल परसों रात
तो फर्स्ट पेज पे देखिए
मैंने कैसे मैंने तो लास्ट में
हाँ हाँ कर दीजिएगा लेकिन रजिस्ट्रेशन इसमें है लिखा हुआ
We will now
हमारी
transition
क्लासेस
into the article discussion segment.
कोई दिक्कत नहीं
Participants will collectively engage with the research titled Revolution